So for a salt, we define a salt as any substance whose hydro formed when hydrogen ions in an acid are wholly or partially replaced by a positive ion, or sometimes we call it a cation, or ammonium ion. So that's when we get a salt. Back in Form 1, that is on the topic of acids and bases. Once we reacted acids with a metal, for instance, we were getting a metal salt and water. So those are some of the salts that we are talking about. After looking at what a salt is or giving a definition of the same, we have 4 types of salts. That is the normal salt, the acid salt, the basic salt, and the double salt. So I'm requesting you to write on the chat. You give the definition of the normal salt, acid salt, and basic salt, and double salt. So let's do that on the chat.
Excuse me,
Yes,
champ.
Carol.
The chat is disabled.
It is not working. Let me work on it. In case the chat is not working, we can raise up our hands and give definitions by word of mouth. So who will tell us what is a normal salt very quickly and give us an example of the same? What is a normal salt? Giving an example. Yes, Delmas.
It is a salt that does not contain any replaceable hydrogen atom. An example is sodium chloride.
Very good, that is correct. Someone has to give us a definition of the acid salts. Yes, Shuri.
And acid salts are salts that contain a replaceable hydrogen atom. Some examples are sodium hydrogen carbonates, potassium hydrogen sulfates, and sodium dihydrogen phosphates.
Very good. But again, we talk of the hydrogen carbonates. We say that you should not give them as examples of acid salts. That is because they are alkalis. For sodium hydrogen carbonate or potassium hydrogen carbonate, they're not examples of acid salt as they are alkalis. Take note of that. Someone has to give us the definition of basic salts. Basic salts. Rari. Rari, give us what is a basic salt. Karoki.
Basic salts are salts that contain hydroxide ions. For example, sodium hydroxide.
Sodium hydroxide.
An example, sodium hydroxide.
Example, someone else who can assist on examples of basic salt. Karoki, that's a good trial. But for sodium hydroxide, that is a base. For the basic salts, we start talking of, for example, basic magnesium chloride, which has the chemical formula, that is MgOHCl. That is an example of a basic salt. Lastly, will give us a definition of a double salt. Definition of a double salt. Yes, Samuel.
These are salts that contain two different cations and anions.
Example.
An example is ammonium iron sulfate.
Ammonium.
Ammonium iron sulfate.
Here we have ammonium iron sulfate. Very good. So those are the types of salts and their examples. So we can continue looking at the solubility of salts and bases in water. For solubility of salts, we need to know that we have mostly the salts are in four types. That is the anionic part of a salt, or the anions represent the salt part. That is the chlorides, the nitrates, the sulfates, and which is the other one? The nitrate, sulfates, chlorides and carbonates. So very quickly, people to tell me on how chlorides behave in water, how nitrates behave in water, how sulfates behave in water. So we raise up our hands. How do the salts behave in water? The chlorides, which ones are soluble, which ones are insoluble? Denzel?
All nitrates are soluble.
Very good. All nitrates are soluble. Any other person?
All chlorides are soluble.
Yes.
Except
Yes. What about the chlorides? Rari, tell us something about the chlorides.
all chlorides are soluble except silver and lead chloride.
We
Lead
have
chloride is soluble in hot water.
very good. The 2-chloride is soluble in hot water. Someone tell us about the sulfates. Sulfates. What about the sulfates? Will tell us on the sulfates. Yes. 076. 076. Answer on sulfates. What can you say about the sulfates? Karoki, tell us.
All sulfates are soluble except barium, lead, and calcium. And calcium is slightly soluble.
Very good. So you have barium sulfate is insoluble. We have lead sulfate is insoluble. Calcium sulfate is slightly soluble. Very good. Then lastly, we have the carbonates. What can we comment on the carbonates? Carbonates, yes, then.
All carbonates are soluble except sodium, potassium, and ammonia.
Very good. And actually, in other words, we say that all the sorts of group 1 elements and ammonium are all soluble. So I'm hoping you're taking short notes on the same. What about we go to solubility of bases? People to give me examples of bases. Examples of bases. Examples, we start by highlighting examples of bases. I think our chat is working now, so you can write down the examples of bases. Give examples of bases. You can see sodium hydroxide. Very good. That is an example of a base. We have sodium hydroxide. We can have potassium hydroxide. We have calcium oxide, magnesium oxide. So who will tell us, we raise up our hands, who will tell us which bases are soluble in water and which ones are insoluble in water? Which bases are soluble in water, which bases are insoluble? Mm-hmm. 26601. Tell us which bases are soluble and which ones are insoluble. (26,601).
The potassium bases, the sodium bases, and the ammonium bases are soluble in water, whereas the rest are insoluble in water.
Very good. So we have that is the group 1 elements, hydroxides and oxides. They are soluble in water. Then when we come to magnesium and calcium, that is magnesium oxide, magnesium hydroxide, calcium oxide, calcium hydroxide, we say that they are slightly soluble. And then all the other metal oxides and metal hydroxides are insoluble. So I hope up to there we have understood something. So we proceed from the solubility of bases. But before that, write down this question. Write down this question. So you can write what I'm typing on the chat. So write down that question. Describe how a mixture of lead sulfate, ammonium chloride, and sodium chloride can be separated. Write the answer down in your book, and then we raise up our hands to answer them. Describe how a mixture of lead sulfate, ammonium chloride, and sodium chloride can be separated. Now let's have people raising up their hands. I'm hoping we have already written down the answer. How do we separate a mixture of ammonium chloride, sodium chloride, and lead sulfate? How are we going to separate the three? Using the concept on solubility, how are we going to separate the three? Anyone who is done answering the question, you give us the answer. We raise up our hands to answer the question. We are using the concept on solubility of salts. Where do we start? Anyone who is willing to answer? Anyone willing to answer that for us? How we separate the three? Neymar, give us the answer. Yes, Neymar. Then let's have Alan.
You first of all you heat the solution because ammonium chloride is sublime, and then you dissolve the solution so that you add water to the solution so that sodium chloride dissolves. Then you filter to collect lead 2 sulfate as the residue.
What do you do with the sodium chloride?
After you filter, you crystallize the filtrate to collect sodium chloride.
That is a good trial. That's a good trial. So as he has said, then remember as you answer this question, you have to avoid the use of you and the use of terms like dissolving. So you can talk of you heat the mixture for ammonium chloride to correct ammonium chloride as a sublimate. Add water to the mixture to dissolve sodium chloride. Then filter to obtain lead sulfate as residue and write between filter papers. Next, you heat the filtrate to saturation to obtain sodium chloride crystals. I hope you have gotten what I've said. Let me type it in the chat. So this is what you are to write. You hit the mixture. Hit the mixture. So in case of that question in the exam, that will be the expected answer. So on separation, mostly we major on the properties of the various salts that we are trying to separate. Mostly they will bring a salt that can sublime, and then salts that are maybe soluble in water. They can even include lead sulfate. Maybe they can include, we can have lead sulfate or barium sulfate and lead 2 chloride. So which property of lead 2 chloride will enable it to be to be separated? That is, if you have a mixture of barium sulfate and lead 2 chloride, what property will enable us to separate the two? What property will enable us to separate the two? Joseph? Yes, Joseph?
Warm water.
Yeah, well, adding warm water to the mixture. What
Yeah.
will dissolve? What will not dissolve?
Mhm.
Yes, Joseph?
Lead 2 chloride will dissolve,
Mm-hmm.
while barium sulfate will not.
Yeah, but barium sulfate will not dissolve and therefore can be able to separate the two.
Yeah.
Okay, that is good, Joseph. And then always remember, when we talk of any mixture, any salt that is dissolving, when we come to, you must have that salt at the end of the day, and therefore you heat it to saturation, then you allow it to cool to obtain its crystals. So that was on solubility and where we apply solubility. So I want us now to look at, I can see some hands which are being raised. Yes, Simon?
I have a question.
Ask.
Okay, the question that you gave us on separation of ammonium chloride, sodium chloride, and lead sulfate. Do you say ammonium chloride sublimes or dissociates?
We talk of sublimation because after it, for instance, if we look at where we talk of, when we correct aluminium chloride, it's going to dissociate and then it's going to itarudiana tena. Sawa sawa.
Okay.
They are going to, yeah, we are going to correct it as a sublimate because they are going to recombine. After this dissociation, it's then going to recombine.
Okay, thank you.
Welcome. Any other question? Any other question? Yes, Joseph. Then if there are no other questions, I want us to now go to methods of preparing salts. We understand that you have both the soluble salt and the insoluble salts. We have 5 methods of separating the soluble salts. I'm going to give a highlight on the same. Then in a revision on the same, we are going to answer a few questions. So you can write down the following methods. We are going to start with methods of preparing soluble salts. One of the methods is direct synthesis. We have direct synthesis. The other method is action of an acid on metals. Action of an acid on metals. Action of acid on metals. Then we have action of acid on metal carbonates. Action of acid on metal carbonates. And the fourth one is the action of acids on bases. Action of acids on bases. Action of acids on bases. And for bases, you have the soluble bases and the insoluble base. So under action of acids on bases, we have a insoluble base and we can also have the soluble base. Then lastly, on the same methods, we look at methods of preparing insoluble salts. Methods of preparing insoluble salts. That is precipitation or double decomposition. We have precipitation or double decomposition. Precipitation or double decomposition. And also direct synthesis can apply there. We can have direct synthesis. And I want us to look at mostly the expected questions as we discuss the various methods. We can write the following questions which are going to guide us. So we can say, starting with red metal, the first question. First question, you can write this. Starting with red metal. Starting with red metal. Describe how lead nitrate can be prepared. Starting with red metal, describe how lead nitrate can be prepared. How lead nitrate can be prepared. The other question, the next question is, have you been able to write the first one? The other question is starting with the copper metal. Starting with copper metal. Starting with copper metal. Starting with copper metal. Describe how copper 2 sulfate. Describe how copper 2 sulfate salt can be prepared. Describe how copper 2 sulfate salts can be prepared. Describe how copper 2 sulfate salt can be prepared. You can work on those two questions. Once you are done, you can raise up our hands. The first one was on red. We are starting with red metal to make lead nitrate. The other one we are starting with copper to end up with copper 2 sulfate. You can see Terence Getao is there. And let's have more people. Yes. Terence is where have you gone? Okay, tell us what question are you answering?
The second one.
Okay, give us the answer.
Burn copper in excess air to obtain copper 2 oxide.
Mm-hmm.
Add excess copper 2 oxide into dilute sulfuric 6 acid. Place the filtrate in an evaporating dish. Heat to boil. Allow it to cool. Dry between filter paper.
A very good trial, Terence. That is good. But I want you to tell us, when we add this dilute sulfuric 6 acid, what are we obtaining?
Copper 2 sulfate.
Copper 2 sulfate solution. Then
Yes.
the next point ilikuwa gani?
You filter the unreacted copper 2 oxide.
Then after filtering,
You place the filtrate in an evaporating dish. Heat to boil. Allow the salt to cool. Then you dry between filter papers.
Okay, that is good. Again, you need to correct on that part of boiling. Do we talk of boiling or do we talk of heating to saturation?
Saturation.
Yeah, you talk of heating to saturation. That is good. So class, this is what you're supposed to write. You can either burn. We talk of burning or roasting. You roast copper in excess air to obtain copper 2 oxide. Then you add dilute sulfuric 6 acid to excess copper 2 oxide to obtain copper 2 sulfate solution. You filter out excess copper 2 oxide, all unreacted copper 2 oxide to obtain copper 2 sulfate solution as filtrate. Heat the filtrate to saturation and allow it to cool to obtain copper 2 sulfate crystals. Then you can dry them between filter papers. That was very good. Boniface?
I want to answer the question of lead. You add excess lead to nitric 5 acid. After that, you filter the excess lead metal. And then you heat to saturation. Then wash between filter and then wash between filter papers.
Come again. Read for us the points you have written down in order.
Okay, so you add excess lead metal
avoid using terms you.
Add excess lead metal to nitric 5 acid. Ensure that the no more bubbles are produced. And then you filter the excess lead metal. Then you heat until saturation. And then you collect the crystals by filtration.
Okay, that is good. Boniface? So this is the expected answer on the same. Add excess lead metal to dilute nitric 5 acid to obtain lead 2 nitrates. Filter excess lead metal to obtain lead 2 nitrate solution as filtrate. Heat the filtrate to saturation and allow it to cool to obtain lead 2 nitrate crystals. Filter out the crystals and dry them between filter papers. That is very good. I hope most of us, we have written that. So a question to you, why are we burning copper metal? Why are we first burning copper metal, not adding dilute sulfuric 6 acid to it directly? Why are we first roasting it? Yes, 26 and 51.
Because copper is below hydrogen in the reactivity series.
Very good. Copper is below hydrogen in the reactivity series. So now assuming the next question, we are not assuming, just write down this question. Describe how you can prepare. Describe how you can prepare sodium hydrogen carbonate. Describe how you can prepare sodium hydrogen carbonate. Describe how you can prepare sodium hydrogen carbonate, starting with sodium metal. Describe how you can prepare sodium hydrogen carbonate, starting with the sodium metal. Yes, Aldi.
Okay, so we first add a pinch of sodium metal into a beaker containing water carefully. So the resulting solution form will be sodium hydroxide. After that, you bubble excess carbon dioxide into the mixture and let it react to form sodium hydrogen carbonate. After that, the resulting solution formed, which is sodium hydrogen carbonate, you heat it to saturation over water bath and allow it to cool to form crystals. After that, you dry the crystals between filter papers to obtain sodium hydrogen carbonate crystals.
Very good. That's very good. So as we have been told, you start by adding a pinch. Sometimes you can also use peanut size, pea size, not peanut, pea size. Other times you can talk of a small piece. So all those terms are allowed to water. So you can add a pea size, add sodium, a pea size of sodium metal to water to obtain sodium hydroxide solution. Bubble excess carbon dioxide through the solution to obtain sodium hydrogen carbonate. Heat to saturation to obtain sodium and allow it to cool to obtain sodium hydrogen carbonate crystals. Filter the crystals and dry them between filter papers. That answer is correct. Anyone with an alternative method? Any alternative answer? Any alternative answer? Any alternative answer apart from that of adding peanut size? Yes. Psionic.
Excuse me, Chair, can you pardon?
That is the answer.
Yes.
Okay, so this is what we say. Add a small piece of sodium metal to water. Add a small piece of sodium metal to water to obtain sodium hydroxide solution. Add a small piece of sodium metal to water to obtain sodium hydroxide solution. Bubble excess carbon dioxide. Bubble excess carbon dioxide. Bubble excess carbon dioxide to obtain sodium hydrogen carbonate solution. Bubble excess carbon dioxide to obtain sodium hydrogen carbonate solution. Heat the solution to saturation. Heat the solution to saturation. Heat the solution to saturation and allow it to cool. And allow it to cool. And allow it to cool to obtain sodium hydrogen carbonate crystals. To obtain sodium hydrogen carbonate crystals. Filter out the crystals and dry them between filter papers. Filter out the crystals and dry them between filter papers. Filter out the crystals and dry between filter papers. Anyone with an alternative answer? Who has an alternative answer? Only on that part of sodium, apart from adding sodium directly to water, what else can we do? Yes, Neymar?
Yes.
Neymar? Yes.
Can you repeat the process?
The process again.
Yes.
Let me type it on the chat. The soda is the answer. No. Kiprop.
Can you heat sodium in air
Yes.
to form sodium oxide?
Sodium oxide.
Yeah.
Yeah, actually, that is the alternative part. You, instead of talking of a small piece, you can talk of burning sodium in air, in excess air, to obtain sodium oxide. And from there, what is the next step after that, after burning it?
You add sodium. You add sodium solution containing carbonate solution.
Can we have carbonate solution?
Carbon solution.
How?
You had sodium oxide in
Maybe I can help.
Yeah.
After burning the sodium in excess and obtaining sodium oxide, you just add the excess sodium oxide to water. Because we said that when we come to oxides, that is all group 1 metal oxides, they are soluble in water. So you're going to add the sodium oxide in water to obtain sodium hydroxide solution. Anyone with a question regarding the same? Anyone with a question regarding the same? Yes, Evans.
Please pardon the alternative solution.
The alternative procedure.
Yes, the one of burning sodium in excess air to obtain sodium oxide.
Okay. So for that part, we only replacing the first part where we were talking of add a small piece of sodium metal to water. Instead of adding the small piece, we are saying you can start by saying burn sodium metal in excess air to obtain sodium oxide. Add excess sodium oxide to water to obtain sodium hydroxide solution. Add sodium oxide to water to obtain sodium hydroxide solution. Bubble excess carbon 4 oxide in the solution or through the solution to obtain sodium hydrogen carbonate solution. Heat the solution to saturation and allow it to cool to obtain sodium hydrogen carbonate crystals. Filter out the crystals and dry them between filter papers. That is the alternative procedure. Yes, can see. I hope you are now okay with those answers. Do you have questions regarding preparation? Ama niongeze swali? So I think we can proceed. You can, we are still on preparation also. we can talk of starting with the starting with the lead oxide. Starting with lead oxide. Starting with lead oxide. Starting with lead oxide. Describe how a salt of lead carbonate can be prepared. Starting with lead oxide. Describe how. Starting with lead oxide. Describe how a salt of lead carbonate can be prepared. We have 26, D61, give us the answer.
So you add excess lead 2 oxide to dilute nitric 5 acid solution. You filter to get lead 2 nitrate as the filtrate. Then you add the filtrate. You then add lead 2 nitrate to sodium carbonate. You filter to get sodium nitrate as the filtrate and lead 2 carbonate as the residue. You then rinse with distilled water and dry between 2 filter papers.
That's very good. Very good. So you start by preparing a soluble salt of lead. And the soluble salt of lead, actually for lead, the only soluble salt is the lead 2 nitrate. So we can only add dilute nitric 5 acid to lead 2 oxide to obtain lead nitrate solution. So if you are writing, you can write this down. Add dilute nitric 5 acid to lead 2 oxide to excess lead 2 oxide to obtain lead 2 nitrate solution. Add sodium carbonate. Add sodium carbonate to the lead nitrate solution to obtain lead 2 carbonate. Filter out the lead carbonate. Filter out to obtain lead carbonate as residue. Wash it with distilled water and dry it between filter papers. So who will tell us which method is that? What method are we applying there when we are preparing the lead 2 carbonate? What method of preparing salt is that? What method is that? And 26 to 22.
Precipitation or double decomposition.
Very good. That is precipitation or double decomposition. That's very good. So I welcome you to ask any questions on methods of preparing salts. Anywhere you have had a challenge, can raise up our hands. Anywhere on our methods of preparing salt, those are the questions that we expect. Mostly they give us the starting metal, or they will give us a starting base. Then we are the ones to know what method are we to apply, depending on the salt that we are preparing. I can see 26 and 58. Yes. $26 and 58.
How can we prepare sodium chloride in a school laboratory?
In school laboratory, who will help us answer that question? How do we prepare sodium chloride in the laboratory? Someone will assist us in that. Anyone who has an idea of what method we can apply there? We have Terence, okay. Tell us.
Just a small piece of sodium metal to water to obtain sodium hydroxide solution. To the add excess sodium hydroxide. Add the sodium hydroxide solution to dilute hydrochloric acid. Place the filtrate in an evaporating dish. Heat to saturation to obtain the sodium chloride crystals. Dry between filter paper.
Very good. But there is a step you have hujataja. And that was good, Terence. So we can actually add water. We can add a small piece of sodium to water to obtain sodium hydroxide solution. And then the sodium hydroxide solution, you add hydrochloric acid to it to obtain sodium chloride solution. You heat the solution to saturation and allow it to cool to obtain sodium chloride crystals. So that is actually a reaction of a base and an acid, and we are talking of a soluble base in this case. So what do we consider when we are reacting a base and an acid, or an alkaline solution with an acid? What do we consider? What are we going to consider there? There are factors to be considered when we are preparing a salt using a base and an acid, or a basic solution and an acid. What do we consider? Yes, 26,601.
We consider the concentration of the acid and the base together with their volumes.
Very good. We can talk of either the concentration, sometimes we talk of molarity. You have to consider molarity and also the volume of the solution. Any other question? Yes, keep up. Keep up. Then we go to Evans.
Would it be right to say that the small piece of sodium metal is supposed to be added to dilute hydrochloric acid? And then, okay, first, add a small piece of sodium metal to water to obtain sodium hydroxide. Then add sodium hydroxide to the diluted hydrochloric acid. Would it be right to add sodium hydroxide to diluted hydrochloric acid?
Yes, there is no problem with that. Remember when we are doing, when we were on the topic of moles, that is titration in the laboratory. What are we doing in the labs? When we are carrying out titration?
If it is a direct titration, we are adding the acid to the base that has an indicator.
Yes, so it is just the one and the same thing. The only thing maybe need to consider, for instance, when we are talking of sodium hydroxide and hydrochloric acid, in what mole ratio do they react?
Please pardon?
When we, for sodium hydroxide and hydrochloric acid, what is their mole ratio? They are reacting mole ratio?
1:1.
1:1. So maybe you can include terms like add equal volume of sodium hydroxide to an equal volume of hydrochloric acid with the same molarity. Mostly when you asked about that question, you're usually given the molarity and even sometimes the volume. Have I answered your question?
Yes.
Okay. Any other question? Yes, Larry?
Will you consider what he said as back titration?
Yes?
Could we consider what you have said as back titration?
What was called back titration?
The fact when you add the hydroxide to the acid, could you consider it as back titration or direct?
It is more of a direct titration because I remember for back titration, mostly we say it's like you are starting the titration from there. You are working the titration backwards. So mostly this one is a direct titration, not a back titration. And again, remember for the back titration, mostly we have the acid is reacting either with the carbonate and at the same time it's going to react with the base. That is mostly what we have when it comes to back titration. So it's a direct titration. Any other question? We have, yes, Adri.
What is the difference between direct, double decomposition and precipitation.
The difference between double decomposition and precipitation.
Yes.
There is no difference. It's one and the same thing. It's only that for precipitation, we talk of precipitation because, for example, if I was to react the sodium carbonate and the lead nitrate, I'm going to see a precipitate. What is the name of that particular precipitate? It is the lead carbonate. Double decomposition, it's because they are exchanging the anions. The lead is taking the anion of the sodium and the sodium is taking the anion of the lead. That's why we talk of double decomposition, but they mean one and the same thing.
Okay, thank you.
Welcome. I can see. So you can write these questions down, this one question down. One of the questions is, both potassium carbonate and calcium carbonate are white solids. Both potassium carbonate and calcium carbonate are white solids. Both potassium carbonate and calcium carbonate are white solids. Give two tests that you would use to distinguish them. Give two simple tests that you would use to distinguish them. Both potassium carbonate and calcium carbonate are white solids. Give two simple tests that you would use to distinguish them. Give two simple tests that you would you would use to distinguish them. Give two simple tests that you would use to distinguish them. Give two simple tests that you would use to distinguish them. And the other question, the second question is, what would you expect to observe? What would you expect to observe? What would you expect to observe? What would you expect to observe if barium chloride? What would you expect to observe? What would you expect to observe if barium chloride and sodium sulfate solutions are mixed? If barium chloride and sodium sulfate solutions are mixed. The other question, explain how you would obtain a pure sample of. Explain how you would obtain a pure sample of. Explain how you would obtain a pure sample of. Yes, keep up.
In the first question, it is the test for solubility. You add a small amount of each solid to separate test tube of distilled water. Potassium carbonate is soluble, forming a clear alkaline solution, while calcium carbonate is insoluble, so it remains as a suspension with no clear solution.
Or you can talk of a precipitate in the test tube containing calcium carbonate.
Yeah.
Yeah, that is good. The answer is good. Who has an answer for the second question? The expected observation for the barium chloride and sodium sulfate solutions are mixed, what are we expecting to see? What will be the observation? Yes, Abdi?
Barium chloride reacts with sodium sulfate solution to form barium sulfate and sodium chloride, respectively. And barium forms barium sulfate is an insoluble salt, which forms a white precipitate.
Very good. So the expected observation is a white precipitate, and he has given us the reason. It's because there will be formation of an insoluble salt known as barium sulfate. That is very good. I can see 815 has raised the hand. Yes, tell us. Okay, so you can write this question and answer it later on. You are writing, explain how you would obtain. Explain how you would obtain. Explain how you would obtain a pure sample of lead-2 chloride. A pure sample of lead-2 chloride from a mixture of lead chloride and silver chloride. Explain how you would obtain a pure sample of lead-2 chloride from a mixture of lead chloride and silver chloride. I hope that we have learned and we have been able to remind ourselves on the types of salts and the soluble salt, the soluble bases. We have also been able to remind ourselves on methods of preparing different salts. So you can actually get more questions and try to answer them. And remember not to use the terms which you advised against, terms like dissolve or you. And if we have anyone with a question or comment, anyone with a question or a comment? Yes, to 22.
It's a question.
Ask.
The last question. When we obtain silver chloride as the residue and silver and lead chloride as the solution. Okay, it's a solution in warm water. Can you just cool to obtain? Can you just cool to obtain a lead-2 chloride solution?
No, you can't just go direct to cooling because remember when you are talking of heating to saturation, some of the water in this solution is evaporating, and that is how most of the water is, we are raising the temperatures. A lot of water is evaporating. So what remains behind is what we are talking of, saturation. You have to heat to saturation. You can't just go direct to cooling. Any other question? Yes, Boniface.
Because lead chloride is soluble in warm water, when the water is cooled, won't it become insoluble?
Oh, by the way, we are talking of lead-2 chloride, which is insoluble in cold water. Yes, actually, 222 was right. We just leave the water to cool down. Once the water cools down, the salt is going to be in crystal form. He was very much correct. Sorry for that. Any other question or comments? Yes, Evans.
Is it right for me to okay, the first question, both potassium carbonate and calcium carbonate are white solids. Give 2 steps you would use to distinguish them. Is it right for me to say that by heating, the potassium carbonate will remain stable and calcium carbonate will decompose to form calcium, carbon dioxide, and calcium and carbon dioxide? Is it right?
Yeah, it could also be right. But in this case, the examiner is testing on solubility. He wants us he wants to know whether we understand the soluble salts and the insoluble salt. Again, when we apply heating to it, it now becomes more of a chemical test.
Oh, okay.
Yeah, so the best is that of adding water. We have no questions. I can see Andre. Yes.
Mine is a request. Could we go through a Form 3 topic in the next session, maybe organic chemistry or moles?
Okay, there's no problem. That is noted.
Yeah, thank you.
Yeah. Yes.
Could you kindly repeat the answer for the last question?
The last question on separation of lead chloride and silver chloride. You have said that you add warm water to the mixture. Add warm water to the mixture to dissolve lead-2 chloride. Filter out to obtain silver chloride as residue and write between filter papers. Allow the filtrate to cool. Allow the filtrate to cool to obtain lead chloride. Allow the filtrate to cool to obtain lead-2 chloride. Allow the filtrate to cool to obtain lead chloride. Yes.
Thank you.
Welcome. Hey, we have no other questions or suggestions or comments, we can meet in the next session. Have a blessed day. Yes, Evans.
Is it right? Okay. Must we mention the fact that when we filter out silver, when you filter out, okay, this question, the last question, add warm water, this is the solution, add warm water to the mixture to dissolve lead 2 chloride, filter out the silver chloride as the residue. Must we mention that part as the residue?
It is not a must. You can just talk
Okay.
over filter out silver chloride and write between filter papers. It still be correct.
Okay.
Yeah.
Then allow the filters to cool to obtain lead 2 chloride. Will there be an excess of the solvent?
And yes, you can even talk of after allow it to cool and filter lead 2 chloride. That will also be correct if you filter out or you just leave your answer at to obtain lead 2 chloride. Both answers are correct.
Okay, thank you.
Welcome. So have a blessed day.